Welcome students to another video lecture with Mr. Connect. As I've prepped you before, this is a pretty long note because of combining a bunch of sections that all are discussing about volume and three-dimensional figures. So be prepared. Go ahead and pause here and copy down what you see. Okay, welcome back. So we're going over in our textbook lessons 12.4 through 12.6. And what these lessons deal with are three-dimensional figures and volume. And we're trying to figure out how to find cross sections of three-dimensional figures, which is kind of like slicing something. And then we're trying to find the volume of three-dimensional figures. Our essential question is, how do we find the cross section of figures? And how do we find the volume of 3D figures? So go ahead and, well, actually you already paused, so we're going into the lesson here. So we're going to talk about a little bit of vocabulary on 3D figures. And you have to realize on this image I'm showing you, I'm not showing you every edge, and I'm not showing you every vertex, but I am trying to get you to understand what the vertex is. And just so you haven't maybe not connected this yet, vertices is the plural of vertex. So the first kind of vocab on any three-dimensional figure we're trying to talk about is the corners. This blue arrows that are being pointed at the corners of the prism are called vertex or vertices if you're talking about many of them. The red arrows are showing the edges of the shape. Those are the edges. And then lastly, we're trying to realize that this rectangular prism above has 6 faces. And I'd love it if you could try to identify all of the faces of this prism. Yeah, so what I want you to start to realize is you have this front face, which is identical to its parallel face. So these two red faces are the same. Okay, so we have those two faces. I'm going to get that coloring to go away. This left part of the prism is the same size as this right side of the prism. So now we've gone through 4 of the faces there, and I'm trying to show you the commonality between different faces. And then we have to find 2 more. Those last 2 faces would be the top rectangle as well as the bottom rectangle. Those are the last 2 faces. So on this rectangular prism, it turns out there are 3 different types of rectangles, but there are 6 faces. And the reason for that is the front and the back rectangle are the same size, the left and the right rectangle are the same size, and the top and the bottom rectangle are the same size. We're going to want to keep that fact in our head because that'll make some of our math easier. We won't actually have to find 6 faces areas in these problems when we start doing surface area, because we'll know that the front and the back are similar, as well as the left, the right, and the top and the bottom. So now we're moving on here, and we're going to talk about cross sections. And oh, wait, it asked about a green line, so I should probably add one in. Let's put the green line vertical right there. Okay. So when we're creating go ahead and pause here and copy down what you see. Welcome back. Okay, so when we're creating a cross section, what you want to do is imagine yourself, you're slicing this three-dimensional figure through the lines we've drawn. So on the bottom part here, let's start with our blue line slice. And the three-dimensional figure here I have is a cone, and I like the cone shape as an example because it's a little more complex, and you end up with very different looking cross sections based on how you slice it. So let's start with the blue slice. Okay, when you slice the blue area and you were to take the top of that cone off of the slice, what shape would the bottom of the slice look like? Yeah, you're right. It looks like a circle because you slice the cone parallel to its base, which also is the shape of a circle. Okay, now let's start talking about the red slice. And the red and the green slices, I think, are a little harder to imagine. So the red slice, we're cutting that cone part at an angle. So it means that this will not be a perfect circle. It's going to be a different shape that we haven't talked a lot about. It's going to be a Yeah, if you guessed, it's going to be an oval. And that's because we've extended it some by cutting it at an angle. So its cross-sectional shape looks like an oval. And now the last question, the green line slice. So when we cut it at the green line, that's like taking, imagine that ice cream cone upside down. And if you were to slice it vertically, straight down, and then look at that slice, what shape did you create on a cone? Yeah, you're right. The bottom of the circle will look kind of like that. And then the cone goes up to a point and down to a point. So that made us a triangle. Okay, so cross sections are trying to imagine what the two-dimensional shape will look like when you slice your three-dimensional shape. And this will be better described in class when we actually have physical objects we're doing this with. So moving on, now we're to the heart of our lesson, our volume. I'm going to go 2 slides ahead. There is actually going to be a third page of volumes here. So go ahead and copy down what you see here. But when you're doing this, please be aware that I'm leaving space because I haven't actually answered this question, which face is the base? That's actually the most challenging part of our section here, is figuring out what the area of the base is and what the base should be. So go ahead and pause now, and copy down what you see. Okay, welcome back. Okay, so we have our rectangular prism. We have a cube, which just is a rectangular prism that has all the same sides. We have a triangular prism, and we have a pyramid. And 2 different types of pyramids, but the formula doesn't actually change. The formula is the same for both of them. The hard part is figuring out what the base shape will be. So first off, this is mentioned a little bit later on in the note, but let's talk about what A subscript B stands for. A subscript B stands for area of the base. So to find these volumes, we're going to need to know which one of the faces is considered the base. And we get misled by using this word base because we always think it means the bottom. But the base is not going to always be the bottom on these prisms. Sometimes it's just better to draw them one way rather than another. So the rectangular prism is going to be a little easier. It's going to be a rectangle as its base. So on the rectangular prism, the base shape is a rectangle. And we are able to choose any of the rectangles of the 3 that are possible on this rectangular prism to act as our base. On a cube, the base shape will be a square. Now the first challenging one is this triangular prism. The way I've drawn the triangular prism, and you're looking at for the base, most of you are about to answer, yes, you're right, rectangle. No. Rectangle is not the base. So you're thinking when you do bases, what shape could you layer on itself without changing the dimensions, the size of its length, width, and so forth when you layer it on itself? Another way to think of this is it's called a triangular prism. So since it's called a triangular prism, the face on the shape that we should use as the base is the triangle. Turns out that's the only shape on a triangular prism. If we were to layer more and more triangles on each other, we would be making this 3-dimensional figure known as the triangular prism. For this first pyramid example over here on the right, the base shape is a triangle. For my second pyramid example, the base shape isn't a triangle on this one. What shape is that? Yeah, you're right. This one has a square. And the reason it's so important that we're identifying which face is the base is because that's going to be the part on this area of the base. We're going to need to use the formula for the area of a triangle on this pyramid. And on the second pyramid, we'd have to use the area of a square because that's what its base shape is. I'm going to go to the last slide finally, and you're going to continue or pause here and copy down what you see. These will be our last 3 shapes we have to know for this lesson. And go ahead and pause here and copy down what you see. Awesome, welcome back. So I have just realized if you're having trouble drawing these 3-dimensional figures, try your best right now and we can edit them in class together. I'll try and give you some quick lessons on how to draw 3-dimensional figures on 2-dimensional paper. That's actually one of the hardest parts, is getting our 3-dimensional shapes on paper, which is 2-dimensional. So we have a cylinder here, and that line up there I should be labeling in the middle of the circle as the radius. And what base shape do we have for the cylinder? Yeah, you're right, it's a circle. It's a circle. What base shape do we have for a cone? Yeah, you're also right, it's a circle. And notice the formula that doesn't follow the pattern of area of the base times height, like all the other 3-dimensional figures here, is the sphere. And the reason the sphere does not have the area of the base in its formula is I want you to look at that sphere and imagine to yourself and think to yourself, what shape would we call the base? Or where would the base even be in a sphere? Yeah, you're right, just like me, I don't see a base, so that's why that is not in this formula. So again, those are all the shapes we're going to need to know. I'm going to jump 2 slides ahead. And as I said, to keep this note a little shorter, I'm going to leave this last problem to be evaluated in class. So these are the last 2 slides of this note. I hope I haven't tortured you too bad on its length. And I can't wait to further explain how to do these volume problems in class. So thank you, students. Remember, if you have any questions, please write down your questions in the questions column, and I'd love to answer those things in class. I'll see you soon.